In this video, let's take a look at the logarithmic functions. We talked about earlier, logarithmic functions are inverse functions of exponential functions, right? We talked about that earlier. You can watch the previous video more about that. So what is it? What is a logarithmic function? So it's actually an inverse function of an exponential function. So if you have a function a to the x, whose inverse function would be log x base a. So what does it do, right? What is it supposed to do? So in general, if you say log x base a, the output, what we are asking is the following question: what is the power of a that will give me x, right? And that would be your output. That would be your y. In other words, what is the value? What is the power of a? What is the value of the power of a that will give you x, right? And that is usually the y. So that's what we are saying right here. So if you say log x base a is equal to y, what we really mean is that is equivalent to a to the y is equal to x. So a to the y is equal to x right there. So for example, if we ask you the following question, what is the log x base 2? In other words, the question is, what is the power of 2 that will give me 8? You're all experts. You know that 2 cubed is equal to 8. So the answer for this would be 3 right there, right? So again, if I ask you the following question, what is the log 100 base 10, which is essentially or popularly known as log 100, the question we are asking is, what is the power of 10 that will give me 100? Again, you're all experts. You will tell me that the answer is 2 because 10 squared is 100, right? If I ask you, what is the log e base e, the question is, what is the power of e that will give me e? Of course, the answer is 1, right? Because e to the 1 is equal to e. So this would be 1. So the answer here is 1. And again, if I ask you, what is the log 1/3 of base 3? The question is, what is the power of 3 that will give me 1/3? You all know the answer is -1. 3 to the -1 multiplicative inverse, which is 1/3. So the answer for this would be -1. Right? So that is how the logarithmic functions work, right? And again, as I told you before, logarithmic functions are inverse functions of each other. Now let's take a look at the graph of logarithmic functions. So if you have the function y is equal to a to the x is like that, as we discussed in the previous video of 1.6. This is basically the inverse functions geometrically or graphically are the reflection of the original function along the line y is equal to x. So if you reflect it, this is the line that I'm going to have, and so which is the log x base a. And here are the graph of the logarithmic functions. So here is the graph of the log x base 10, log x base 5, x base 3, and x base 2. As you can see, the larger the basis, it's going to be smaller the y value, right? Of course, you need to have the base is the higher, then you need to have larger value to reach that. So that is what you're going to have there. And a couple of notes about the logarithmic functions. As I told you before, log x base e is the popular function ln of x, which your calculator has, right? So whenever you see ln of x in your calculator, what we are talking about is the log x base e. And when we say log x, that's without any base. By default, the base is x. So again, whenever you see in your calculator log x or computer log x, which is basically means log x base 10. And as I told you before, logarithmic functions are inverse functions of exponential function. We know that if f of x is log x base a, then the inverse function would be a to the x, and vice versa. If you say g of x is a to the x, the inverse function g inverse of x would be log x base a, and vice versa. So what is it important? So I want to quickly combine these two together and tell you log of a to the x of a, which is basically what we have here is, if we go with the language of f, what we have is here we have f composed with f inverse of x. If f composed with f inverse of x, as you know, these are inverse functions, will give you the x as the value. And similarly, the other way around is also true. What do I mean by the other way around is also true? A to the log x base a is also equal to x. And we need these properties to solve logarithmic and exponential equations. We're going to see that. As a matter of fact, we're going to use this to solve these problems in a moment. So let's again recollect these functions, the properties. Log a to the x base a is equal to x, and a to the log x base a is equal to x. So in general, if I write it down, what I can say is the following: log 10 to the x base 10 would be x. Log or ln of e to the x squared would be x squared, because ln and e are inverse of one another. And log 2 to the x cubed minus 1 base 2 would be x cubed minus 1. Ln of e to the 3 would be 3, and so on. I can keep on doing that forever. Again, the idea here is the base and this is same, then the power would be the output, right? The power would be the output, because ln is the log base e, x cubed minus 1. Again, here base is 2, so the output would be that. And that comes from this particular property right there. We'll do more problems like that, but I just want you to remember these properties. All right, let's take a look at some more properties of the logarithmic functions, and then before we solve these problems. The property number 1, or the laws of logarithm, or logarithmic property number 1 is, if you have two entities x and y, you multiply and take the logarithm, is essentially same as finding the logarithm first and adding them together. Similarly, if you have two quantities x and y and you divide them first, assuming that y is not equal to 0, and take the logarithm, which is essentially same as finding the logarithm individually and subtracting them. And if you have the power r, x to the power r of the logarithmic function, you can bring the power to the front. So you can say this is r times the log ax. Similarly, your calculators have only ln and log, right? So if I ask you to find the log x base 3, your calculator is not going to do that. Then how do I find that? Here we can use this particular formula right there. This particular formula says log x base a is equal to ln of x divided by ln of a. So you just find the ln of x in your calculator, ln of a in your calculator, and you divide them. It's easier to remember. Remember, a is the base, so that goes on the bottom, and x is on the variable that goes on the top right there. So yeah, log x base a is equal to ln of x over ln of a. There are a few other properties that are corollaries of these properties. Let's take a look at them, because we're going to use them to solve problems. So what are those properties? Property number 1, I'm going to call number 5. Log a base a is equal to 1. We already talked about it, right? Because what is the power of a? That would give you an a. Of course, a to the 1 is equal to a, so therefore the output is 1 right there. Similarly, another property, log 1 base a. I don't care what the base is, as long as base is positive, base is not equal to 1, this is always going to be 0. In other words, what is the power of a that will give me 1? That is always going to be 0, right? So that's what that one says. And the third property that again we're going to be using a lot is log a to the x base a. I think we looked at it as the inverse is always going to be x right there. So to bring it to things that we're going to use it in general, ln of e is going to be 1 all the time. And ln of 1 is always going to be 0. And ln of e to the x is always going to be x, right? In general, I'm going to say ln of e to the some function h of x, right, is equal to h of x. If you want to remember this in a funny way, think of this. Ln of e to the chicken is equal to chicken, right? So whatever is the power of e is going to be the output over there, and that is something we are going to be using again and again and again, right? I think we are ready to now solve these problems. Let's solve these problems. I think before we solve, let's take a step back and solve an easier problem, and then we will come back to this guy. So let's take a look at this problem. Let's solve e to the 2x is equal to 5. How do we solve this problem? So the way that we're going to solve this problem is, what we're going to do, because it's e and the exponential, we have the exponent as the 2x. My variable is the exponent, right? So what we are going to do, we are going to, we're going to take natural logarithms on both sides. We're going to take natural logarithms on both sides. So I'm going to write it in short, TNLOBS. If you want to be funny, if you want to remember this in a funny way, think of this as a TN lobs, or it's a Tennessee lobsters, right? I'm going to say in a funny way as Tennessee lobsters. Whenever I use the word, it's not Tennessee lobsters, by which I mean we're going to take logarithms on both sides. What do we mean by that, right? Algebraically speaking, what do we mean by that is, so you have the expression e to the 2x. As a matter of fact, any expression, we are going to apply ln on both sides. What do I mean by that? Is I'm going to say this is ln of e to the x, and this is going to be ln of 5. That is what we mean by taking natural logarithms on both sides. Using the calculator, you can compute this value, right? Using the calculator, you can compute this value right there. So I'll let you do it. I think if you compute the value, you're going to get the value to be 1.60944, but let's not worry about it now. Now what we're going to do, we're going to use the property, one that I gave you right here, to simplify this right there, right? So ln of e to the h of x is equal to h of x, right? So now ln of e, so therefore this is going to give you, I can bring the power down, right? Another way of thinking. So that is my step 1. In my step 2, you bring the power down, you have times ln of e, which is equal to ln of 5. And again, what is the ln of e? If you remember what is the ln of e, I said which is equal to 1 right there. So you can say this value is 1, and this value is 1. So what you have here is you have 2x times 1 is equal to ln of 5. You really don't have to write it that way. You can simply write from here, simply this as 2x is equal to ln of 5. You can do that. Again, coming from this particular property right there, ln of e to the h of x is equal to h of x. You can do that, but if you want to see in more details, we can do this way as well. Now that we have the equation 2x is equal to ln of 5, our goal is to solve. So now I'm going to divide both sides by 2. If I divide both sides by 2, what I get is I get x is equal to ln of 5 over 2. If I plug this into the calculator, what I get is I would get my answer to be 0.8047 dot, 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 dot. Up to 4 decimal places, I will stop it right there, right? So that is the solution. That is how we would solve, in this case, an exponential equation. Again, let me repeat it. The very first and important step is taking natural logarithms on both sides. Tennessee lobsters in a funny way. That means ln of e to the x is equal to ln of 5. And then now you bring the power down. And then you have the equation 2x is equal to ln of 5 or ln of 5. Then, of course, algebraically you divide by 2 on both sides. You get the value right there, right? That is how we would solve it. Now let's try to solve this particular problem, right? How do we do that? We're going to do the same thing in here, but now we're going to be actually applying natural logarithms twice in an iterative way. Let's do that. So step number 1, I'm going to take natural logarithms on both sides. So what I'm going to have ln of e to the 2x, which is equal to 100. So if it apply the ln, it's going to be ln there. Now the power is this, right? The power is this. So I'm going to bring the entire power down. So then if I simplify, ladies and gentlemen, that's my step 2. What I have is I have e to the 2x times ln of 2, which is ln of e, which is 1. I don't need to worry about it. It's equal to ln of 100. We will keep it like that. We can figure out the ln of 100, but let's not worry about it too much. We'll figure out that value later. As a matter of fact, ln of 100 would be 4.6057, but let's worry about it later. Let's keep it there. Now I still have the e there. Now how do I get rid of the again? So we're going to repeat that one more time. How do we repeat it? We're going to take the natural logarithms on both sides. If I apply my Tennessee lobsters, so I have ln of e to the 2x is equal to now ln of 100. And now here what I have is my power is 2 to the x. So the power comes down times the ln of e, which is equal to 1. And then what I have is I have ln of 100. And so now if I divide both sides of the equation by 2, what I get is I get my x to be ln of 100 divided by 2. If you plug this into the basic scientific calculator, what you're going to have is you're going to have 0.7635 dot, 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 right? I think we'll stop it at the 4 decimal places. And that is how you would solve an exponential equation. Now, how do you find this particular value? I think we are going to use the property number 4. We're going to use the property number 4 to find the value. Let me copy down the property number 4. Okay, copy this guy. So what I have is I have ln of, that's my step 1, ln of x base a is equal to ln of x over ln of a. So therefore what I have is I have the log 10 base 5, which would be ln of 10 divided by ln of 5. If you plug this into the calculator, you're going to get the value as 1.4306. Dot, 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 dot. So that is how we would do that. That's very simple. Let's solve some more problems. How do we find this one? We're going to use the property that I mentioned earlier, the definition of the function. If you remember what I said before, if we ask for what is the log x base a, the output that we are looking for is what is the power of x that would give you, what is the power of a that would give you x, right? So now what is the power of 2 that would give you 32? One way to think about it. So what is the power of 2? What is the power of 2 that would give you 32? If you're very good with the numericals, you know that this is 2 to the 5 is equal to 32, and then you would say the answer is right away 5. There's another way to do. So whenever you see a base, another way to think about this would be, can I write this term? Can I write this guy in terms of powers of 2? Yes, I can. So now I have log 32 base 2. So can I write this 32 in terms of 2, in terms of powers of 2? Yes, I can in this case, which would be 2 to the 5 is 32 base 2. And if you simplify this, we're going to say we can bring the power down, again using the property number 3 right here, using the property number 3 right there. I can bring it down. So if I bring it down, I'm going to have 5 times log 2 base 2. Again, since the variable and the base, they are one and the same, that is going to be equal to 1. So this is 5 times 1. The answer is 5. That's another way to do that as well. Or the third way to do would be, so there's a one way, the second way. The third way to do would be log 32 base 2 would be ln of 32 divided by ln of 2, which may not necessarily give you 5. It might give you maybe a number approximate close to 5, and that's perfectly okay. So if you try to do this using a calculator, ln of ln of 32 over 2, it gives you like a 4.99 something. I think if you have a very fancy calculator, that might give you the answer as 5, but that's okay. That'll give you a close approximation, right? It might give you probably 4.999999 and or some calculators might give you as the answer as 5. So there are 3 ways to solve this problem. Let's take a look at how do we solve this logarithmic equation. So it's not an exponential equation. What we have is a logarithmic equation. So whenever you have a logarithmic equation, what we are going to do, we are going to apply the exponential function. So we're going to basically use this particular property that I mentioned earlier. So we're going to use this particular property that we're going to use there. So we're going to, whatever the base is, we're going to raise it to that particular base. So what do we mean by that? Now here what we are going to do, we are going to taking exponential on both sides. So if you want to call it TE OBS, I don't know, how do you want to say it in a funny way? I'll let you do that. So it's taking exponential on both sides. What do we mean by that is that, so you look at the base in this case, it's ln. So therefore the base is the E. So in this case would be, the step 1 would be taking exponentials on both sides, right? Which would be E to the ln of 2x is equal to E to the 3. Now, as I told you before, exponential functions and logarithmic functions are inverse of one another. So in a way, this would give you the output as the 2 to the x on this side. So the only thing that would give you be survive would be 2 to the x, which is equal to e cubed right there. Now you divide by 2 on both sides, and that will give you the answer as x is equal to e cubed over 2. And I'll let you use the calculator to figure out this numerical value, whatever that would be. And how do you solve the next problem? Again, this is a logarithmic function. So we're going to do the step 1 just like we did before earlier. We're going to take exponential functions, in this case e, raising it to the e on both sides. If I do that, what I'm going to have is I'm going to have e to the ln of 3x minus 10 is equal to e squared, or e to the 2. Now, as we did before, ln and the e are inverse of one another. That's going to go away. What you're going to have is you're going to have my left hand side to be simply 3x minus 10. The right hand side is going to be e to the 2. Now I'm going to add 10 on both sides. If I add 10 on both sides, I'm going to have 3x is equal to e squared plus 10. Now I'm going to divide by 3 on both sides. If I divide 3 on both sides, that would give me my answer as x is equal to e squared plus 10 divided by 3, which would be, use the calculator, you should get the answer as 5.79635 approximately. I think it might go on forever, but that's the answer approximately for this problem. That is how we would solve this logarithmic function. I let you do this particular problem, right? Here you have to use the exponential function in an iterative way, and I'll let you figure out the answer for this. All right, I will stop it right here, And this completes the section 1.6 and also the chapter 1 as well. The next video we will look into chapter